Hello, welcome back to the Math Tutor channel, and we are going to talk about let's do some mechanics today. Mechanics, you can put it in physics and math. Okay, so the question is on the screen. I hope you can read it clearly. A block B of mass 2.7 kilograms is pulled at a constant speed along a straight line on a rough horizontal flow. Okay, the pulling force has a magnitude of 25 newtons and acts at an angle of, okay, the angle is theta above the horizontal. The normal component of the contact force acting on B has a magnitude of 20 newtons. Okay, so show that we have a question. Okay, so in this question we are going to take G to be 10 meters per second squared, the acceleration due to gravity. Alright, so let's go. So always in mechanics we start by sketching. We start by a sketch. So we have a horizontal rod or horizontal line. There is an object, and this object has a mass of 2.5. so we know that the weight acts downwards, and it is given by mg. W equals mg, so 2.7 times g. The g is 10. Okay, okay, so they told us in the question that the magnitude, the force is acting at an angle. So the force 25 newtons and is acting at an angle, that angle there. And then they said the normal component, normal, when you borrow some idea from math, normal is a line that is perpendicular to a horizontal line. So basically they mean this normal component, so the vertically upward, no, the reaction force of the 2.7 g, and that makes this is 20 newtons. Okay, 20 newtons. Well, they also mentioned that the rough is, I beg your pardon, they also mentioned that the road is rough, but according to the questions they have asked, the roughness is not going to affect our calculations. So even if we don't consider it right now, we shall still get the answer. Okay, let's start. Yeah, so this is the illustration of the question. Now we are ready to go. Okay, so we've not left out anything. Okay, so part I, they're asking us to show that sine of this angle is 0.28. Perfect. So we know that the force 25 newtons has two components. Okay, it has a vertical component of 25 newtons, and it will be given by, when you draw it here, it will be given by, it will be 25 sine of theta, sine of the angle. Okay, if we wanted the horizontal component, let's write the horizontal component of 25. Since it is in between directions, it will have two components, so this will be 25 cos theta. Okay, I hope you know how to resolve forces. Okay, so basically we have this. So the vertical components, when you resolve this vertically, it will be facing the same direction as the 20 newtons. Okay, so since we know that weight, the downward forces are equal to upward forces, we shall use that assumption, and we shall say 20 plus 25 sine will equal to 2.7 g. Okay, so let's make sine theta the subject. So 25 sine theta is equal to 2.7 times 10, because g is 10, and then minus 20. Okay, so dividing by 25, sine will be 27 minus 20 over 25, which gives us 7 divided by 25, and checking on a calculator, 7 by 25 gives us exactly what they told us to prove. So this here is the answer to I. So we can say hence shown. Okay, hence shown. Okay, I hope part 1 was okay. You understood it very well. So let's do part 2. Find the work done by the pulling force in moving the block at a distance of 5 meters. Okay, distance of 5 meters. Okay, just a minute. Okay, I'm trying to zoom in. Okay, find the work done in moving a force. Find the work done by the pulling force in moving the block at a distance of 5 meters. Okay, alright, so we know that work done is equal to, since this is an inclined force, so work done is given by this formula. Okay, so we already know the force is 25. Okay, and we know the distance, but we need to know the value of the cos theta. Okay, okay, so this is work done. So since we know sine theta is equal to 0.28, this is II. Since we know that sine theta is equal to 0.48, theta will be the sine inverse of 0.28. And checking the sine inverse, you make sure your calculators are in the deg mode or the degree mode. Okay, since this is in degree, not radians, not gradians, so 0.8, the sine inverse of 0.8 gives us 16.26 degrees. Okay, 16.26 degrees. Alright, so I'll change the color to white. Now that we know that this, remember we want cos theta. Okay, taking you back to the diagram. So this is, I'll change the color. Okay, so this is 16.26 degrees, which is okay. Now we already know that this side, the distance pulled is 5 meters. Okay, now we need cos, so we shall say cos theta is equal to 5, beg your pardon, just a minute. Okay, so we have the angle, we need to get the hypotenuse. Okay, yes, we need to get the hypotenuse, because this is we are considering this triangle. Hope you're still following. We are considering this triangle here, and it is a right angle triangle, so we are going to borrow ideas from trigonometry. Okay, so we are going to say cos of 16.25 is equal to 5 over the hypotenuse. Okay, the hypotenuse, I'll write it like that, the hypotenuse. So the hypotenuse that we need will be 5 divided by, what is cos of 16.25, checking, so 5, it is 0.96, so 0.96, so 5 divided by 0.96, we get the hypotenuse as 5.21. okay, so this distance here is 5.21. okay, now since we know that the hypotenuse is that, So we shall now say work done is 25 times 5 times cos is 5 over 5.21. okay, so 5 divided by 5.21 is giving us, actually it's giving us this. Wow, this is so good. So now we shall have 25 times 5 and times 0.95, okay, 96. Okay, we can round it off to 96, and then we shall now work out the work done. 25 times 5 times 25 times 5 times 0.96. There we go. So our work done will be 120. You can give the answer in joules, or you can give the answer in Newton meter. Okay, so this here is the answer to this question. Okay, I hope you understood. You can see the working. I hope you are following, and I hope this helps you get your grades in math mechanics. Thank you very much for watching, and make sure you subscribe, share with your friends. Don't get a good grade alone. It is always lonely at the top, as I always say. See you in my next video. Bye bye.